There we go. Okay, starter. Let's try these.
Alright. Squared is 36. Minus 4 squared is minus 16.
And what does squared mean?
Times by itself.
And what is a minus times a minus?
It would be 16.
Yeah, anything squared, it'll never be negative. Okay, next one.
Yeah,
16 again. And last one.
1.
That's it. Okay. Do you already know how you would do this one? X to the 3 times x to the 4.
Yeah. Wait, what are we supposed to do?
So you have to simplify it. So
X times it.
So x to the 3 is x times itself 3 times. X to the 4, x times itself 4 times. And you're multiplying them. And so overall, what is that?
X to the power of 7.
Yes. And so this one down here.
2 to the power of 11.
What is the quick way of going from having 3 and 4 to just 7?
Adding them together.
Yep. Copy the base, add the powers. That's a quick way of multiplying. Okay, let's try these.
Alright. That is 5 to the power of 10. Next one is a to the power of 9. And x to the power of 6. And what does it mean by, n is 5? No, 6.
Well done.
6 times.
Yep, and a 6. That's fine. Okay, multiply indices. Let me just see something. Yep, what you give yourself there?
Tick.
Dividing.
I'm guessing you just minus.
You do. Basically, that's 3 A's. That's 2 A's. A divided by A is 1. A divided by A is 1. And you're left with just A times 1 divided by 1, which is just
A.
Yep. X to the power. X just by itself is the same as x to the power of what?
X to the power of 1.
Yep. Okay. Let's try these. This top one. This time we've got numbers in front.
Would it be 6x to the power of 11? 9.
Well done. I think you're good. And so it's normal number times normal number, same letter times same letter. Okay, how about this one?
20x squared. 20x to the power of 5, y to the power of 9.
Very good. Okay, let's try these.
Uh, 5x to the power of 6, and y to the power of 4. Ten a to the power of 5 and b to the power of 4. Um, 28a to the power of 4 and b to the power of minus 10.
You're not multiplying these, you're adding those.
Oh, adding, yeah, b to the power of 3.
Well done. So it's a minus, you're just taking it away. Multiplying indices with 3 terms.
Tick.
Yeah, great. Great. How did we do dividing again? What would this top one be?
Take it away.
And so what would this be? What would I simplified it?
Wait, should I answer?
Yeah.
5 to the power of 4.
That's it. That's fine. Let us see. What is top middle?
H to the power of 6. 5.
Yep. And let's have a go at top right.
G minus 14 to the power of 6.
It is. You just copy the base g minus 7 to power 6.
Oh.
That only came up once on an exam. I'm not too worried. Dividing. Okay, let's try this one.
Uh, 4a to the power of 3.
And let's just try one dividing. Let's try question D.
3w to the power of 2.
Great. And so over and divided by, same thing. Okay, 3 terms.
Uh, 3x to the power of 2 and y to the power of 4.
Okay, exam questions. Let's try them.
8a to the power of 4 and b to the power of 3.
Yep, it isn't 8 though. For normal numbers, not index numbers, it's just dividing.
Oh yeah. This one 5.
Yeah, and so that's going to keep happening where it's just a mix up because it's a mixture of dividing and subtracting. Same way with the previous one, it was a mixture of multiplying and adding. Okay, next one.
Um,
There's a little trick in this.
2m to the power of -2
Mm-hmm.
and t to the power of 4. 3a to the power of 6. I mean 4. And f to the power of 6.
And like the previous one, the smaller
Oh yeah,
number.
minus.
Yeah.
-4.
Yeah, everyone makes that one. Okay, dividing 3 terms.
Tick.
So that's multiplying 3 terms, dividing 3 terms. And so what you'll notice is, you know, so I did 1, 2 terms, and the exam questions have 3 terms, and so that's what you have to work towards. Okay, a mixture of multiplying and dividing.
Right.
Let's start with the bottom one.
T squared.
Yep. And so t to the 8 over t to the 6, and so t squared overall. Exam question. I'll let you pick one.
First one is n to the power of n to the power of 4.
Yep, that's grand. They're both about the same. Let's see. Those ones, I think you're all right. Okay. A squared cubed is the same as a squared times itself 3 times. What does that simplify down to?
A to the power of 6.
Well done. What is the quick way of going from having 2 and 3 to just 6?
Timesing them.
Yes. And so power to a power, you multiply them. How about this one?
A to the power of 6.
Okay, let's try these.
2 to the power of 7.
No.
Oh wait, let's multiply. 2 to the power of 12. 6 to the power of 10. 4 to the power of -6. 5 to the power of 12.
Great. Exam questions. Let's try bottom left.
8. 50. X to the power of 15.
Let's try middle.
H to the power of -6.
And top right.
X to the power of 6.
Well done. Let me see something. Okay. What is this one?
Would it be 6a to the power of 6?
You have the right idea. What is 2 cubed?
2 cubed. That's 8a to the power of 6.
Yes. And so, like always, it's a mixture of to the power and multiplying. So it's always a mixture of 2 different things. And so it's easy to mix them up. Okay, let's try these. Harder than they look.
25x to the power of 2. 8a to the power of 12.
It would be 2 cubed is 8. 2 to the 4.
Oh, 16a.
Yep. And last one.
Nine p to the power of 10 and q to the power of 8.
Well done. That's with 3 different terms.
So it's like lots of numbers give me a headache and letters and stuff.
So the reason why I'm doing that is because the exam questions will have 3 different. It'll work towards it. Okay. Exam question.
27x to the power of 6.
Yep.
6x on a 2 cubed. 8x to the power of 18 and y to the power of -3.
Well done. Let me just check. Yes. So what do you give yourself for those power to a power?
6.
That's good. So we did multiplying indices up to 3 terms, dividing indices up to 3 terms, and then powering indices up to 3 terms. This one, a to the 6 divided by a to the 6.
A or 0.
Well done. A to the power of 0. And what is anything divided by itself?
To the power of 0 or
Yeah.
1.
Yeah, it's also 1. And so what that shows you is anything to the power of 0 must be equal to 1 because it must have been divided by itself. Yeah, so anything to the power of 0 is 1. Lots of exam questions. What are the answers?
1.
Mm-hmm.
1.
Yep.
1.
Mm-hmm.
1.
Mm-hmm.
So also 1.
Anything to the power of 0 is 1. Yep. Power of 0?
6.
Yeah. You'll probably make a mistake, but everyone does, but we'll see. Okay, let's try these. 3 times a third. And 3 is the same as 3 over 1.
Oh, we 1.
Yep.
That would also be 1.
Mm-hmm.
So the next one. 8 times 1/8.
Mm-hmm.
7 times 1/7.
The reciprocal of a number is what it must be multiplied by to make 1. So the reciprocal of 3 is a third. The reciprocal of a half is 2, and so on. Okay, what's the reciprocal of each of these?
1/6. 1/11. 4. 9.
That's it. How about these?
divided by 13.
Top left.
Also left. 2. Oh,
2 times 3, 3 times 2.
is this multiplying fractions?
Yeah, so you're just multiplying across.
Oh, all right. Not on a 6 over 6, which is 1.
This one.
This would be 28 over 28, which would be 1. That would be 55 over 55, which would be 1.
Now top right. 6 over 13 times what makes 1?
13 over 6.
Very good.
8 over 9. And 10 over 17.
Well done. And the reciprocal is what you have to multiply it by to make 1. And so the reciprocal of a fraction, you just flip the fraction. And in fact, 6 is the same as 6 over 1. So the reciprocal, 1 over 6. These ones, I need to change that because you can use a calculator. We'll do non-calculator first on the bottom.
2 over 1.
Yeah. And what is 2 divided by 1?
1. Oh, 2 divided by 1.
Just 2.
Oh, it's 2.
B.
5 over 2. 4 over 15.
Then how do we do D?
Minus 5.
What would this be as an improper fraction?
It would be 5 and 2/3. 7 over 3.
17 over 3.
Oh, 17 over 3.
And so the reciprocal?
3 over 17.
That's it. These up here are calculator. You can do them with or without, whichever you prefer. And so 5A. Oh, yeah, whatever I prefer. Go on.
How would you find the reciprocal of 8?
What times 8 makes 1?
1.
If we go back to here. So what if part was 8?
Uh, 8 times 1.
That'll make 8. We wanted to make 1.
Oh. 8 divided by 1. 8 over 1.
That's the same as 8.
So it'll be 1 over 8.
Yeah. Hold on. How do you do B?
0.145. You convert that into fractions. It's 29 over 200, so it'll be 200 over 29.
It's a weird one.
4.8. So 4.8 is equal to 1 and 2 halves. Oh no, 1 and 2.
It's
1 and
there is an easier way. Let me show you. So the one before it, 1 over 0.145. So you can just do 1 over and you get 200 over 29. So in the same way 8, it was 1 over 8, you know. So what would you put in your calculator for C?
5 over 24. Is that the answer?
Yep, 5 over 24. That's great. And D.
3 over 2.
Well done. Great. That's reciprocal. Okay. This was non-calculator paper. This was calculator paper.
Write down the reciprocal of 5. It would be 5 over 1.
5 is 5 over 1.
Oh, 1 over 5.
Yeah. And how about this one?
4 over 5.
Well done. 1 sec. Yes. So reciprocal of a number.
6.
I think we're about to use it for something. Yes. What is the answer here?
Is 8 over mine. Oh no, not x to the power of minus 3.
Yep. And then another way of writing it is over instead of divided by. If you did it that way, it would cancel down to be that. And so it would be 1 over x to the positive 3. So what that shows you, the same question written 2 different ways, 2 different answers. The answers must be equal. X to the minus 3 is the same as 1 over x to the positive 3. In general, any number to the minus is the same as 1 over that number to the plus. And so if you have a negative index, you just do the reciprocal and it becomes plus 1 over. Okay, let's try these.
All right. It would be 1 over a to the power of 7. 1 over b to the power of 8. 1 over 3 to the power of 3.
I think you get the idea. And then how about going backwards?
P to the power of minus 8.
Yep. How about very last one?
T to the power of minus 1.
Well done. Let me think. And sometimes you can make them simpler. Like 3 to the power of 3 is 27. So you could say that's 1 over 27. But sometimes it'll be like 7 to the power of 9, which is some enormous number. And so it's like, let's just probably just leave it like that. These questions, they're terrible. And they're in a terrible order. I think you do something with these. What I need to do, what would be question A?
Question A. 3 to the power of minus 2 is 1 over 3 to the power of 2.
And can you simplify that?
1 over 9.
And I'm just going to leave it there with those ones. Yes, algebra. H to the minus 3. What's that the same as?
1 over h to the power of 3.
And then what is this one? Simplify.
Uh, minus 3t.
Power to a power?
Oh, t to the power of minus 1.
You multiply them.
Oh, t to the power of minus 6.
And so t to the power of minus 6 is the same as?
1 over t to the power of 6.
Well done. And so if you have a power of negative, you can write it as 1 over. Exam questions. Let's try these.
Five to the power of minus 1 is 1 over 5 to the power of 1. 5.
And can you make this one a little simpler, I suppose?
Yeah, 1 over 5.
Yeah, just 1 over 5. Okay, how about this
Um, 1 over 5 to the power of 2. 1 over 25. Does evaluate mean the same thing?
Yeah, it means your answer will be a number. It won't have like X or anything like that in it. Same
All right. 1 over 3 to the power of 2, which is 1 over 9. 1 over 10 to the power of, oh, just 1 over 10.
Mm-hmm.
1 over 10 to the power of minus 2, oh, it's the power of 2, which is 1 over 20.
10 squared?
Oh, I mean, 1 over 100.
And this one.
1 over 2 to the power of 3, which is 1 over 8.
Well done. Negative powers, those ones. What do you give yourself?
Oh, tick.
I think that's all right. Let's see. Yes. Okay, this thing. Square root of 25 times square root of 25.
Not really sure. Just be a 1.
What is the square root of 25?
Oh, 5. 5 times 5 is 25.
25 to the power of a half times 25 to the power of a half. What is a half plus a half?
Oh, 1. So,
it's like 25 to the 1.
oh, right.
What do you know about 25 and 25 to the 1?
No, the same.
And so, something times itself gives you 25. Something else times itself gives you 25. What does that show you? That shows you that these two must be the same as each other. So 25 to the half is the same as square root 25. What do you think 16 to the half is the same as?
Square root of 16.
Yep. And what is square root of 16?
4.
Yep. And so to the power of a half, basically anything to the power of a half is the square root of that thing. Okay, cube root. Cube root of 1,000. Any idea what that is?
Is it non-calculator?
Yeah. What times what gives you 1,000?
100. I mean, 10.
10. Okay, how do we do the next one?
Would it just be 8?
Well done. How about next one?
It would also be 8.
What does that show you?
They are the same.
Yep. Let's see. Anything to the power of a half, square root. Anything to the power of a third, cube root, and so on. And so that's how you deal with. So we did positive indices, we just did negative indices, now we have fraction indices. Let's try these. Okay, question B.
121 over half is equal to square root of 121. 1 over 49.
Hang on. Non-calculator. Square root of 121.
11.
Yep. That's 11. Yeah, okay. How about question A?
We 49 to the power of root 49, which is it? I'm not sure.
7. In this case, 1 over 7.
Oh. Yeah. Oh, yeah.
How about F?
It would be root 4 over 9.
Yep. And so what is that?
4 over 9.
Square root 4, square root 9?
Oh, square root 4 is 2, square root minus 3.
Yep.
2 over 3.
Yep. 2 over 3 times 2 over 3 gives you 4 over 9. How about... okay. This one.
It's equal to cube root of 8. Which is equal to 8.
What cubed equals 8?
Oh, 2.
Yeah. How about B?
Cube root of 125. There's cube root of 125, which is 5.
Well done. I think we get the idea there. Power of a half, square root, power of a third, cube root. Let's see. I'm happy with what we did. What'll be very last one? H.
That'll be the cube root of minus 64 over 125. Should be minus 8 over 5.
That's right. A D.
Oh, not minus 8. Minus.
Take a guess.
I'm not sure what cube root of 64 is.
4.
Oh,
And what's
oh,
weird?
right.
What's weird about cube is it gets very large very quickly, and so it's always going to be a much smaller number than you think. Terrible questions. No. Okay, exam questions.
Right, Ln value of. It would be a square root of 9, which is 3. It would be cube root of 27, which is also 3.
Yep. Let me see. Okay, fractional powers.
Tick.
I want to use those fractional powers if I can. What's A?
Oh. Square root of x. X. I mean, x is power of 2.
Yeah. Because x squared times x squared gives you x4. How about C?
3.
Nope.
3x. Oh.
Oh, you're looking at B. C.
Oh. Oh, sorry. Oh, B.
You said 3x. You got it. C.
2x over. I'm not sure.
It will always be half because it's power of a half.
Oh. Oh. Yeah. B over 4.
And so D, 3 terms.
No. 6. It would be 4x. It's power of 2, and y is the power of 3.
Very good. Nope. Yep. How about this one?
B. I'm not sure.
To power of a half is the same as square root.
Oh, we're at square root of 3x to the power of 4, and y to the power of 1.5.
Yep. Let's write this 3 over 2. So let me see something. Those ones I think were good. I think there might be more to them. Yeah. Now we bring 2 different things together. Any idea how we do first one?
25 to the power.
What is your target grade?
So I'm not sure.
What grade do you want?
Like, above 7.
Okay.
All I can really say.
If we have time, we can come back to this stuff. It's more of a grade 9 thing. Okay.
Should I ask?
No, I just want to. I don't want to. I want to do our test and make sure. If there's time at the end, I'll go back to those. Or
All right.
yeah. No, if you insist. Hang on. Okay, so A, you have a power of a minus and a half. And so how would you do that?
Uh, you would. I'm not sure.
It is 1 over 25
Oh, right.
to the positive. And what is 25 to the half?
Uh, square root of 25. So 1 over square root of 25.
Mm-hmm.
So 1 over 5.
Yep. Hold on a second. How about A?
It would be 1 over 49 to 1 over to the power of half, which would be square root of 1 over square root of 49, which would be 1 over 7.
Yep. And so it's just mixing together two different things that you did separately. Okay, test day is best day. Test your best.
Alright, x to the power of 12.
Mm-hmm.
Would be 7a. Oh no, it would be a 10a to the power of 5. And b to the power of 4. That'll be t to the power of 5. This would be a 3 to the power of 3a to the power of 4 and f to the power of 6.
Small number on top, big number on bottom. So it's 1
Oh,
minus.
minus 4.
Yeah.
Would be 4. N to the power of 4.
Yep.
This would be 14. B14. B14 over b to the power of 14.
Mm-hmm.
Be 27x to the power of 6 and y to the power of 12.
Great.
2 to the power of minus 4. I'm not sure.
1 over.
Oh, 1 over 2 to the power of 4. Should be 1 over the root 4 over 2.
2 to the
Oh
power
no,
4.
we halved. It will be 1 over 2 to the power of 2.
What is 2 to the power 4?
2 to the power of 4. That is 16.
That's it.
Alright.
So 2 to the power minus is 1 over. How about this?
5 would be 5. Oh no, it'll be m to the power of minus 5. Minus 5, yeah. Oh no, minus 10.
And
Um,
how else can you write that?
10 to the power of 0 is 1. That is 1 over
No,
6.
that's power of minus.
Oh yeah, that'll be What is it? Is that 1 over 16 to the power of 2?
A half means square root.
Oh, alright, square root of 16, which is 4. And 7, that is cube root of 27, which is 3.
That's it. So we have to do divided 3 terms, fraction negative. So the stuff that's always difficult. Let's try this one here.
The divide, so it'll be 5a to the power of 4 and b to the power of 3.
Yep. How about this one?
1 over 5 to the power of 2 should be 1 over 25.
And this last one.
Uh, be square root of 9, which is 3.
Well done. That's it. And so indices in general. What do you give yourself?
Say a tick, nicely.
Yeah, that's great. And so, yeah, you were able to do all of them. These have a mixture of, they always have a mixture of two different things. So in this case, dividing and subtracting. In this case, multiplying and adding. In this case, powering and multiplying. So that's why you can easily make a mistake there. To the power of a negative is reciprocal. To the power of a fraction is root. How was that for you, Jed?
Yeah, that was good. Yeah.
So that's everything for indices. So what we could do next, what follows on well from indices, is something like standard form, or if you get your calculator, we can do the trig. Do you have any preference? Or something else?
No, I don't mind. Whatever you think is best.
Okay, so I'll say standard form or finish trig, depending. If you get a calculator. Any questions for me in general?
No, thank you.
All right, well done, Jad. You did great. I look forward to chatting again next week.
Have a good day.
You too. Goodbye.